Hello all. In this video session, we will be discussing about structure and union. Now, structure and union comes under this user-defined data type. Okay, both are user-defined data type. Now, what is a structure? Structure is a user-defined data type, and the structure allows us to define new data types which can contain data items of different types. So structure is a facility that allows us to create data types which can contain different types of data. Okay. Now how we can define a structure? This is a syntax for defining a structure. We use a keyword called struct, struct, and after the struct keyword, then structure name, that is name of structure, open curly braces, then data type variable 1, data type variable 2, data type variable 3. Okay, then close curly braces, then semicolon. Always remember, whenever you are defining a structure, after putting the close curly brackets, you should put a semicolon. Okay. Now this is an example for creating a structure student having members, roll number and name. Okay. So struct keyword is used, then student, which is the name of the structure, open curly braces, then int roll number semicolon, then char name of 20 semicolon, then close curly brackets, then semicolon. Okay, this is how we will be defining a structure. Okay, now we will see how we can declare structure variables. We have defined a structure student. Now how can we declare variables of those variables of structure? So syntax is struct structure name, then structure variable semicolon. For example, we have defined a structure student. In order to create a variable for structure student, we can do so by using the statement struct student, then s. Here s is the structure variable, and when we declare like this, then memory is allocated for s by the compiler. We are considering int as int takes 4 bytes, so in s roll number will be taking 4 bytes and name of 20 will be taking 20 bytes. This is how the memory will be allocated, okay, when this statement is executed. Okay, now we will see how we can initialize structure variables. Okay, so here the syntax is struct structure name structure variable, same as the declaration, then equal to, inside curly braces we can give the value separated by comma. Okay, for example, in the structure student we can initialize by struct student s is equal to, inside curly braces, first roll number, so I am giving 1 comma, then there is, we should provide the name, so inside double quotes I am writing Arun. Here it is a string, that's why it is written inside double quotes, then close curly brackets, then semicolon. This is how we initialize structure variables. Now we will see how we can access structure elements. Okay, this is how the memory is allocated. Now consider that inside this structure variable I want to access the member, roll number, or the member name. Okay, in order to access the members of the structure or elements of the structure, dot operator is used. Okay, for accessing roll number inside us, we will be using s dot roll number. For accessing name, we will be using s dot name. Okay, so this is a program to demonstrate structures. So I have included studio.h, then defined the structure student like we discussed earlier. Then inside main, I have declared and initialized the structure variable s, which is equal to 1, and Arun, which is actually the name. Then I have then there are two statements of printing the roll number and name. Okay, I'm just going to compile this program, and then now I am going to run this program. Okay, so the roll number is printed as 1 and name is printed as Arun. Okay, now here value is initialized and that value is printed. Now I'm just going to give input from the standard input. Okay, that is using keyboard. So I have declared the variable s. This is one way of declaring variable. The another way is that we can declare structure variables here as well. Okay, so both methods are acceptable. And now we have declared the structure variable s, that is struct student s. Now I'm going to write statements to read values from the user. Okay, so enter the roll number, then scanf statement for reading the roll number. Here it is integer, so percentage d, then ampersand s dot roll number, then printf, enter the name, then scanf. So I am going to read every single character till a new line character is encountered. That is, it will read all characters including the blank spaces as well. Okay, for that I am writing a regular expression, that is percentage C, in which it should not be, that is not of backslash n and any number of characters like that. Okay, and it should be stored in s dot, sorry, not here, here, s dot name. Okay, so I have read s dot roll number, then s dot name, then I have printed those values. Okay, there will be one problem while reading the name. Okay, after we compile and execute, we'll see that, and after that I will just solve that problem. Okay, so I'm just going to compile this program, then I'm going to run this program. Asking for roll number is going to give 1, and here what happens is that after I entered 1, there was a backline character which is in the input buffer, and while executing this statement it will accept that backslash n, and since it is backslash n, this statement will exit. Okay, so it will, once this sees this backslash n, it won't read any other values. That's what happened here. So in order to remove this enter or backslash n from the standard input, I'm just going to give here get chr. This will actually is to remove the new line character from the input buffer. Okay, so after taking that, executing this statement will take the backslash n. Okay, so I'm just going to give the statement, I'm going to save it, then I'm going to clear this, and then I'm going to compile it, then I'm going to run it. Okay, roll number I'm just giving 1, and the name is Arun. Okay, Arun Mohan. Okay, so it is now executed correctly. Roll number 1 and name Arun Mohan. Okay. Okay, now next topic is union. Union is similar to structure. It is same. The syntax for defining, declaring, and also for accessing elements are same as that of structure. Okay, now I'm just going to go through the how we can define union. The syntax is, the keyword used is union, and then after that union name, open curly braces, then data type variable 1, data type variable 2, data type variable 3, then close curly braces, then after that semicolon. Like structure, here also after the union is defined we should put a semicolon. For example, consider if you want to define a union data with members character member C, integer member N, and double member Dn, then it can be written as union data open curly braces char C semicolon int N semicolon double Dn semicolon, then close curly brackets and then semicolon. Then how we can declare union variables? Okay, the syntax is union, keyword union is used, then union name, then union variable semicolon. Okay, for example, for the example data union that we defined in the previous slide, the syntax for creating the variable is union data d, and it will allocate memory like this. Okay, now if you observe in this, the largest data type is double, which is 8 bytes. So the space for the largest element in the union is only allocated, that is 8 bytes is allocated, and it will be used by all the variables, that is C, N and Dn. Okay, so that is C, N and Dn. So if C, we can only use one variable or one member of union at a time. Okay, so here the largest size element, or the element with largest size, is the size of the variable D, and inside that we can only access one of the data item or one of the member at a time. That is, I can only access C or N or Dn at a time. Okay, and this is how the memory will be allocated. Memory allocated, or the size allocated, will be equal to the size of the largest member. Okay. Now accessing union elements, it is similar to structure. Dot operator is used to access C. I will be using D dot C. For accessing N, I will be using D dot N. For accessing Dn, I will be using D dot Dn, where D is the union variable. Okay. Now we will see the difference and similarities between structure and union. The similarities are that they are both user-defined data type, and for accessing members of the union or structure, or elements of the union or structure, we will be using dot operator. Okay. Now the differences: for defining structure, the keyword struct is used. For defining union, the keyword union is used. Then this is an example like we discussed earlier. So okay, both are here. A structure is defined, and here a union is defined for a data. And when inside data we have members char C, int and double dn. For in the case of structure, memory is allocated for each variable. Okay, for each member of the structure, or each element of the structure, memory is allocated. But in the case of union, only the size of the largest member is allocated. Largest member is double, and here the size is 8, so only 8 bytes is allocated. Okay, so these facts are explained in the below differences. That is, size of the variable is equal to the sum of individual size of structure members, but in the case of union, it is the size of the largest element. Then in the case of structure, memory is allocated for distinct memory locations for distinct members, but in the case of union, memory is allocated okay, common memory space is allocated for all the members. Then here, since memory is allocated differently for different members, it can be accessed simultaneously. But here, in the case of union, the members of union can be only accessed only at a time, only one at a time. Okay, now here all the memory locations are allocated, so it is less memory efficient. But here only the size of the largest member is allocated, so it is more memory efficient. These are the differences between structure and union. Okay, thank you.